Hi everyone, and thanks for joining me on this week's psychology topic of correlation versus causation on Psyched with Setmire, which is me. Hi. So what we're going to do today is we're going to look a little bit at the topic of correlation. We'll talk about what is a correlation and what is a variable, what is Pearsons R, and then we'll explore the idea that correlation and causation aren't the same thing. Looking at a few examples like global warming and pirates, the relationship between eating pizza and cutting your cancer risk, and even what Facebook users share being lower grades. So thanks for joining me today, and let's go ahead and jump in and talk about correlation versus causation. Alright, so what is correlational research? When we're looking at correlations, which is a really common method of research in psychology, we're examining the naturally occurring relationship between two or more variables. And all that means is we're going to take two things that naturally exist and talk about how strong is the relationship between them. So we don't manipulate anything, we don't change anything, and we'll talk more about that later. We're just going to observe, the naturally occurring relationship between two variables. And a variable is just anything that can have different values between different individuals, maybe just over time, an element, feature, or factor that's liable to vary or change. And this can, again, literally be anything. So you could look at what is the naturally existing relationship between SAT scores and GPA? What's the relationship between attendance to your psych class and how well you do on the exam? Hopefully, you would hope for a strong relationship. So I have two lists of variables up here, and you could take any variable from list number 1 and talk about its relationship to any variable on list number 2. And so, for example, I would hope that there is a strong correlation between IQ and GPA, or number of hours spent studying and GPA. Versus there might be a very weak concentration between how much money you earn every year and the number of moldy containers in your fridge. So you can take any two things and talk about how strongly or even how weakly they might be related to each other. When we're talking about how strong or weak the relationship is, we can examine that in two different ways. We can look at a graph, which might kind of give us a visual idea of how strong the relationship is between two things, or we can use a number, and that number is known by the Pearson product moment correlation coefficient, or very simply Pearsons R. And this is just a measure of the strength of that correlation between two variables. And Pearsons R ranges from -1 to +1. The closer you are to -1, the stronger of a negative relationship you have, and the closer to +1, the stronger of a positive relationship between two variables. And if we were at 0, you could think about this on a continuum, 0 would be no relationship. And so here is what you would see if you looked at it in chart form or in a graph. Here on the left, we have a very strong positive correlation. Notice how we have a line going up. It says the R is 0.85, so very close to +1, very strong. Here in the middle, we have a very strong negative correlation. All the little dots, all the pieces of data cluster together around a line, and the correlation here is -0.96. Again, almost -1, very strong. And here, the data looks largely meaningless and random. So you can see that the line is very flat, indicating that we have a very slight, if not no correlation here of 0.02. So we can look at correlation not only as a chart or a graph, but also using Pearsons R to see how strong the number will be, again between -1 and +1. So as I mentioned earlier, with correlational research, you don't really manipulate any of the variables. You're just studying and measuring what's naturally there. But one of the things that our media loves to do is kind of play around with the idea of what is causal versus what's just correlational. And as it says up here, need to prove something you already believe? Statistics are easy. All you need are two graphs and a leading question. So you can literally, as I mentioned a moment ago, take any two variables and talk about their relationship. So let's take a couple of variables that are a little bit silly, or at least probably have other factors to them, and see how we can make it look like they might cause each other using a graph, a very common media trick. So first example, let's take the idea of the amount of consumption of ice cream and then drowning deaths. So if you take these two items together and you plot them onto a graph, it looks like we have a very strong positive correlation, meaning that the more ice cream that people eat, the more drowning deaths that occur. So the headline that you could make here is that eating ice cream leads to drowning. And I sure hope that isn't true, because I am a huge fan of ice cream. And I even have this little picture here, right, of this person holding an ice cream cone above the water, just in case they survive, right? The ice cream will be okay and ready to eat. So clearly, just because ice cream consumption and drowning deaths go together and have a correlation, it doesn't necessarily mean that they cause each other. A third factor that might cause both of these would be time of year. In the summertime, people are more likely to eat more ice cream because it's warm. They're also more likely to swim, right, which might lead to more incidents of drowning. So it's not that ice cream consumption causes drowning or that they're causing each other, just that they're naturally related. And again, a third factor, such as summer or maybe time of year, temperature, might be causing both of them. One more kind of a funny example, global temperature versus the number of pirates. So if you were to plot global temperatures over time and the number of pirates over time, it might look to someone who didn't know that correlation and causation aren't the same thing, that these two things are causing each other. That as the number of pirates have gone down over time, right, so global temperatures have gone up, right? So what we can say here is that the lack of pirates in the world is causing global warming, right? Obviously that's not the case. There are probably several other factors at play, but with these charts we can kind of manipulate knowledge, and the media loves to do this. But remember, correlation does not mean causation. Just because two things have a naturally existing relationship doesn't mean that they cause each other. You can take any two variables and talk about their relationship, but oftentimes there's a third or fourth or even just multiple variables that might also be important or be kind of influencing what we're looking at. Let's look really quick at a few examples of actual headlines that have made it into the media or the press in some way. And again, you can see how we've taken two things that are related and maybe skewed it or presented it as causal rather than just simply correlational. So first one, in the LA Times, beer tax hikes drive down gonorrhea rates. So when the price of beer goes up, teenage gonorrhea goes down. This would be a negative correlation. But this headline implies that beer and the price of beer is the one thing affecting gonorrhea rates. Now obviously maybe as people drink less, they make more responsible decisions, use more protection, which might influence gonorrhea rates, but there might also be other factors at play. Sugar rush to prison. Study says lots of candy could lead to violence. Now I personally love candy. I eat probably way more of it than I ever should. But I've never been arrested, knock on wood, right, for any kind of violent behavior as an adult. And this article says that children who eat too much candy might be more likely to be arrested for violent behavior as adults. Now there are probably quite a few other factors at play here, but this headline implies that candy causes violence. Eating pizza cuts cancer risk. Now if this were true, I would eat pizza all the time. And I tried to use this piece of evidence here with my partner to say that we need to eat more pizza, and sadly it failed horribly. But the idea here is that pizza is thought to be linked to cancer. Right? If you read this article, it claims that eating pizza regularly might reduce the risk of esophageal cancer by 59%. Again, there are probably other factors at play. What else, or what is it about the pizza that might be cutting cancer risk? What else are these people eating all this pizza doing that might be playing a role as well? Texting improves language skill, right? How are we defining language here? That is something I would definitely like to know. And looking at how it might have an impact on reading. What are the other factors at play? I don't know about you, but I'm not sure that texting necessarily improves our ability to write papers and our language skill and ability to read. So asking those questions, what else might explain these results? What is the other factor? And finally, what do Facebook users share lower grades? According to this article, right, using Facebook is going to cause you to fail your classes, think you're flunking out of school. Again, there are probably other things happening here, right? How are we defining using Facebook? What do we mean by lower grades? Are there third, fourth, and fifth factors that might also play a role in this headline? But this is a very common thing that we do in the media. Take an idea that's probably purely correlational in nature and present it as something very causal. So always have a little bit of caution and be a critical consumer of the information that you see in the media. Alright, so as a quick review of today's lesson, correlation examines the naturally existing relationship between two or more variables. And remember, a variable was just anything that can vary or change over time. We can measure the strength of a correlation through a numerical indicator called Pearson's R. Remember, that went from -1 to 0 to +1. Or we can view the strength of a relationship by a graph. Also remember, a big lesson of today, that correlation doesn't equal causation. Remember, they're different things, and causation can only be determined by things like an experiment, which we can talk about on another day. Any two variables can be presented as correlational or having a relationship, so always be a critical consumer of headlines and any kind of information presented to you in the media. Thank you for joining me today on Psyched with Setmire. What we'll do next time is we'll look at the movie Lucy and talk about the 10% myth, the idea that we only use 10% of our brain or 10% of our brain power. Hope to have you join me then.